Hey guys, today we're going to be talking about transversals and some definitions that go along with them. Now, there's a lot of vocabulary in this video, so I do apologize for that, but something we got to talk about. So, I'm going to start here. We've talked about intersections of lines before, right? How two lines intersect and we create four angles from that. Vertical angles, supplementary angles, all that kind of thing. Today we're going to be taking that one step farther. Actually, we're going to be talking about a very important element of geometry in this video. What happens if this line kept extending down and it got intersected by another line? Now let's say we have line A that goes through here, and let's call this line B. Well, this would create a second intersection of lines, right? A second set of four angles. Let's call it angle 5, 6, 7, and 8. Now we have two lines being intersected and a total of 8 angles in our diagram. Now I have an important piece of vocabulary about this diagram. This line right here, a line that intersects multiple other lines, creating intersections, is known as a transversal. Now you're often going to hear me kind of casually refer to this general shape of a diagram as a transversal as a whole, but specifically the transversal itself is this line going right through the center there. Now, what we're going to talk about vocabulary-wise is how these angles kind of pair up and relate to each other. Because we have some terminology that relates the angles in the first intersection to the angles in the second intersection. Okay? And we're going to kind of start figuring out and noticing some patterns in these vocabulary as we go along. Let's start, though, with the very first term, corresponding angles. Now, the definition that I have here, kind of the note for the definition, is angles that are in the same place. What that means is angles that are both in the, for example, top right-hand corner of the intersection. So let's look here. In this intersection, what's in the top right-hand corner? Well, angle 1, right? And what's in the top right-hand corner of this one? Angle 5. So therefore, angle 1 and angle 5 are corresponding angles. We can keep doing this for all of them, actually. Top left-hand corner, angle 2. Top left-hand corner, angle 6. This is what I mean by angles in the same place. That when we have this intersection, you know, if we were to compare it to a graph, like this is quadrant 2 or quadrant 3, you can think of it like that, or you can think, you know, bottom left corner, bottom right corner. But these are our pairs of corresponding angles. These 4 pairs. Let's look at our next definition. Alternate interior angles. And after all of these terms, angles does come after it. But I just wrote alternate interior, but it is alternate interior angles. We have 2 notes for this definition. These are angles in different intersections, because all of these relate angles from one intersection to another intersection, okay? But they are on opposite sides of the transversal. Now let's recall, specifically in this diagram, the transversal is this line going down the center. So to be on opposite sides of the transversal, one would need to be on the left side and one would need to be on the right side. It also says it's between A and B. Now, when I say A and B, I'm referring to line A and line B. You can see that here. Line A, line B. So when I say between them, it means in the space, quite literally, between the lines. So we need to find a pair of angles that fit both of these definitions, that are on opposite sides of the transversal, one on the left, one on the right, and that are between our 2 lines, and of course are from different intersections. Well, that fits 2 pairs here. 3 and 5 is one of them. Opposite sides, and then both of them are between A and B. So 3 and 5 is one group. Our other group is 4 and 6, because again, opposite sides, and they're both between these lines. Now, would 3 and 4 work? They are on opposite sides. They are both between the lines, but all of these terms, again, relate angles in our first intersection to our second intersection. These are in the same intersection, so that's why those don't count. But these are our alternate interior angles. Alternate exterior. Well, opposite side of the transversal again, left and right, but now it's on the outside of A and B, meaning that instead of being in between this space, it's out here. So let's look at our opposite sides. 2 and 8, opposite sides of the transversal. Both of them are on the outside of our lines. So I'm going to write that down here, 2 and 8. And then our other pair, 1 and 7. We can start maybe realizing some of the terms in our vocabulary relate to parts of this definition. The alternate part of our vocabulary refers to the opposite side of the transversal. The interior part says that it's between those lines, that it's inside those lines, right? The exterior part says it's on the outside or the exterior of those lines. That's where we get some of these words from. Let's look at these last two. Same side interior. Well, instead of alternate being on opposite sides of the transversal, I bet you can guess, same side means on the same side of the transversal. So both of our angles are going to be on the left side, or maybe both of our angles are going to be on the right side. And since it says interior, it's between or inside these lines. So what 2 angles are on the same side in between here? 3 and 6. And what 2 angles are on the inside over here? 4 and 5. So those are our pairs of same side interior. By this point, I know you can just guess this last one, same side exterior. Same side of the transversal, exterior meaning outside of line A and B. So 2 and 7, and 1 and 8. So here's the deal. Usually whenever we introduce vocabulary like this, we have to take some definition and then eventually extrapolate it to whatever we're working with and try to figure out, well, in my example, what does it apply to? Or how does that work there? Here's the great thing with these in a transversal. This is the only way a transversal can work. There's not like 70 variations of transversals. All of them are 2 intersections of lines with those 4 angles. And every single time we talk about alternate interior angles, we're talking about 3 and 5 and 4 and 6. We're not ever going to change that. You're not ever going to have to adapt that to whatever you're looking at or what you're working with. It's always going to be these same 2 angles, that same definition. Presuming, of course, you number your angles in the same way I did. If you number your angles 5, 6, 7, 8 or something, yeah, things could be off because your diagram isn't formatted the same. But if you number your angles the same way I did, these relationships are always going to be true for these definitions. All right, guys, if you have questions about this, feel free to let me know. Otherwise, thanks for watching.